All right, hello everybody, and welcome to the Nix track. You might have been wondering when you saw the time plan, Nix track at Haskell. What does this have to do with Haskell? In fact, probably it's hard to be a Haskeller these days without hearing about Nix all the time. People talking about it, some people liking it, some people disliking it. Never really stopping to explain what it is, why it's relevant, why should we care about it in the Haskell ecosystem. So it's my great pleasure to introduce Malte, a friend of mine who is one of the maintainers of, one of the people deeply involved with dealing with Nix for Haskell infrastructure in a organization we call Nixpkgs. He will explain all of that. Hopefully he will answer the question of what is Nix and why it's relevant to us, how we can use it as Haskellers to improve our lives and without giving up any of the nice things we have when working with Haskell. Malte is a software engineer who has the great fortune of working with Haskell at Heilmann Software, where they write functional reactive applications for the web. So he's also great to talk about that with. So let's hear it from Malte.
Thank you. Welcome to the Nix track. This is supposed to be a workshop. This is supposed to be interactive. So please ask me questions all the time. We are not that many people. That means more questions per person, and I can help you more directly. That's great. I will tell you a little bit about what we're going to do today. So I have a few slides prepared to give you an introduction in the beginning, but I jumped in a little bit on a short notice, so this can be also a little bit collaborative. So if you have any questions, just ask them, then we can. I'm glad to talk about all of this, but we can start with my slides, and then we will have some exercises. So I will talk about what is Nix, and I will try to make it a little bit specific from a Haskell perspective what Nix is. And I will talk about why would we want to use Nix. Then I will shortly tell you how you can do Haskell with Nix. And that's basically it. And then I have prepared a small number of tasks which you can follow to easily set up a Haskell project with Nix. We can go through what that all means. And if you don't have a project, some small, big, whatever project that you want to set up with Nix, you can just create one with Cabal in it or something and try out the various exercises. Some of them are optional because, the Nix ecosystem is like the Haskell ecosystem, full of alternatives and competing approaches. I'll try to be a little bit unbiased, but I'm probably not going to succeed at that. And I guess this is all something we can do maybe in the first hour. This is going to be a 2-hour track, right? So in the second half, I will give probably another input where I talk more about how Haskell actually works in Nixpkgs or on NixOS, how it's packaged there. That has different reasons. So the first part is it's just when you're using it, it's helpful a little bit to know how it looks behind the scenes. And what you can expect and what you cannot expect. Because sometimes the interface might give you wrong expectations about what should work and what should not work. And with that understanding, you might be well equipped to work more with Haskell in Nixpkgs. And then, so the last task is very open-ended. For anyone who wants to try it, we can even try to upstream a package to Nixpkgs and fix it there. That can be very easy. It can be very hard. We will see what happens. So. I have prepared the tasks. I will show you a QR code shortly. I haven't vetted them very thoroughly, so this is also supposed to be interactive. If something doesn't work, maybe we can figure it out together, or you'd ask me, and I'm sure then we will get something working. So first I want to ask you a few questions. Who has heard about Nix? Right, okay. Who has heard about Nix before reading about this track? Yeah, that was to be expected. Who of you already uses Nix? Okay, that's nearly all of you. Who uses NixOS? Okay, I mean, that's roughly half. Okay, great. Who has a nix-shell in one of your Haskell projects? Okay, yeah, probably the same half. I'm not sure exactly. And who maintains a Haskell package in Nixpkgs? Okay, yeah, we got to change that. I can just say Nixpkgs is one of the greatest collaboration projects on this planet, in my opinion. So, yeah, I think everyone should participate in it. But today, first we learn how to profit from it, which is nice. Okay. Yeah, a little bit about me. If you've seen me online, you have seen me probably with this avatar. And yeah, I am a Nixpkgs Haskell maintainer. I'm doing Nix and Haskell since about 10 years. And I work at Heilmann Software, and as where we work full stack on Haskell, front end and the back end, and we deploy everything with Nix. And we currently are a team of 8 developers, and we want to become a team of 9 developers. So if you speak German and are interested in programming Haskell, you can talk to me after this. Okay, so I need to zoom out a little bit.
That is your company, by the way?
What?
Where is this company located?
You can work remote from all over the world, basically. Although European time zone is nice, we sit in Stuttgart. So now I need to zoom so you can read the QR code. Here we go. So under this URL, you can find the tasks in the README. It's probably better to first listen to me and then later start with the tasks. But if it's too boring what I'm saying, then just start right now. The QR code will be shown again later. So let's go. So what is Nix? There is already it's already a very overloaded term. So let me give you a map at the beginning. Nix is a package manager. Oh, yep. Now I need to zoom in again. Nix is a package manager. Nix is a functional, pure, lazy programming language. Then there is Nixpkgs, which is a huge repository with package descriptions to build basically all software in the world, at least nearly all open source software. And there is NixOS, which is a Linux distribution based on Nixpkgs. Let's get a little bit more into the details about this. And we start with the package manager. The package manager is centered around one central concept. It's the Nix store. You can find it whenever you have Nix installed, nearly on all systems. It is at /nix/store. That's easy. So, and what's in there? A whole bunch of directories and files, and they are all hash addressed. So, what's so nice about this store? Where are my notes? Here they are. Okay. 1 second. I'll zoom out a little bit because the slide is slightly too large. Okay. First, there can be basically any data in the store, and it's hash addressed. Some of the data can actually be content addressed, so the hash is a hash about the contents, but often the hash just is a hash about everything that went into constructing that asset, that directory. So it is still easy to not confuse them, I guess. You can have multiple versions of the same library compiled with different flags or whatever. Everything is neatly separated. And the Nix store is immutable. You can write new directories, but if it's written there, the hash is fixed and the content is fixed, it will not be changed again. It contains references. In one of the directories, you can have metadata linking it to another reference, and then you can garbage collect it, because some of the paths you want to keep, those are the roots, and then other paths are linked from those roots, and everything else you can garbage collect. So we have an immutable store for data, which contains references and can be garbage collected. And if this sounds a little bit like the Haskell heap to you, that's not a coincidence. The idea behind Nix was to take ideas from function programming, declarative programming, and see if they can be applied to package management. And this is, Elko Dalstra did this in his PhD thesis, I think around 2008. 6, right, better. And that is, that's the whole magic, really. Like the rest of this talk is corollary, a lot of bash scripts and learning some commands. But this is the whole idea. Now, I told you in the image I have hash name .drv and one path without drv. So what does this mean? DRV files are derivations. And a derivation is an instruction to build a package. So here I have a super simplified example for how to build a package. This is completely wrong. It looks much more hairy in reality. But the derivation contains a builder attribute. And there we get the source from somewhere. Then we execute a build command. In this case, I'm executing cabal build. And then we copy the path, the results to the output. That's basically it. That doesn't work exactly like this, but that is the whole concept. So some of the store paths are instructions how to construct other store paths. And the important part of the Nix package manager is basically you write derivations and you execute them to create other outputs. And so then let's get to the next. Any questions until now? No. Yes? Oh, sorry?
Can you make the font bigger?
Oh yeah, zoom in.
I think we can make the font bigger on the next slide, because on this slide it will overflow. So, what is Nix lang? Yeah. Yeah.
Yeah, what's the difference? Maybe you'll get it. What's the difference between a .nix file and a .drv file?
Yes. Yeah. Okay. I can. No. Let's talk. Let's talk about this in a second. The question was, what's the difference between a .nix and a .drv? So, let's talk about Nix lang, the Nix language, often also just called Nix. That is, it contains the .nix file. It's in the .nix file. That's right, and it is, I'm afraid, the most successful lazy pure functional programming languages in the world. At least according to my very questionable data from Google here. But I don't think that is really a problem for Haskell, since it's really not the best, and it's also not general purpose. Still, it is basically a mix between an untyped lambda calculus and JSON. And this is just an example. of how Nix can look like. So the column there, that's a lambda. So we are binding the x, then we have a let bind, and we are adding stuff, multiplying stuff. Yeah, and all the language constructs you can just you can read about in the Nix language tutorial on nix.dev, or you will see a little bit more in the next slides. So, okay, now we get to the question, what's the difference between a Nix derivation and a Nix file? So, the Nix language is a pure functional programming language, and it basically has exactly one side effect. And this side effect is writing derivations to the Nix store. Everything else is pure, but there is a primop in the language which takes an address set with, or a dictionary with some data, and constructs a derivation file, writes it to the Nix store, and then it can continue and knows the name of the derivation file, and when describing the next derivation can contain a reference to the previous derivation. Yeah, this is how it works. And this phase we call instantiation, or just eval. And then there is a second step, and this is executing the package description from the derivation, right? And well, that is when actually the building of a package happens, where compiling happens, and this step we call realization, or just build. Some of the Nix commands, they muddy a little bit, or they do it just in one step, and you can even interleave them and do a little bit of the first, then of the second, then of the first, and then of the second. But for me, this part is very, very helpful to understand the distinction. And it's noteworthy that you actually don't need the Nix language to interact, to use the Nix package manager. You could just use another language to produce derivations, and then use the Nix package manager to build the derivations. The only problem with that is that there is already this very huge, very helpful collection of a lot of derivations in the Nix language written in Nixpkgs and other packages all around the world, or GitHub. And so practically without Nix language interoperability, all approaches to producing derivations are not that useful. Okay, there's a question. Let's go.
What's the language the derivation is written in? Is it also Nix or something else?
No, the derivation itself is not Nix. It is a serialization format of which I recently read the name, but what? A-term, yes, exactly. I would have said something close to that. Excellent. It's called A-term, and it looks a little bit Lispy, I guess. Some parentheses, some comma. We can just look at one. I think it's isomorphic. Yeah, if you use nix-shell, well, it contains tuples, so I'm not sure if it's completely isomorphic to JSON. But yeah, well, you can do it with lists. Yeah, I guess it works out. We can probably have a look at the derivation later. Okay. So that's the Nix language. We will see snippets of Nix language later. And let's go on to Nixpkgs. So, yes?
Do derivations also have functions, or are they like, do they evaluate to just data structures?
So the question was whether derivations also contain functions. And I would say in the intending meaning of the question, the answer is no. It's really basically more or less like JSON. It just contains data. A lot of the data in there are phases, so-called phases, which are small bash snippets which describe what to do during the build phases. And so technically, there are bash functions in there. And in theory, in corner cases, you can also have some derivation write Nix code to the store, but this gets very confusing. And then you can load the Nix code again and continue from that. That happens, but that it's not the central use case. But it can be useful at times. So let's get on with Nixpkgs. This is, I basically have already said what this is. It is a GitHub repository with thousands of contributors every year, and it has a lot of commits, and it describes a lot of packages. Everything in the open source world. Some closed source software has also derivations in there. You just need to enter a license key to build it or something, or provide the source. And yeah, so every NixOS release claims that Nixpkgs is the largest and most up-to-date repository of packages in the world. I think that is probably true, but it's very hard to measure. Repology has data about this, and for example, every Hackage package is in Nixpkgs. We mirror them automatically, but not all of them build, because I mean, there are packages there from 15 years ago on Hackage, which no one uses, and it wouldn't be feasible to get them all. And Joachim Breitner actually at one point made a pull request to Repology to filter out packages marked as broken, so they don't count against our package count. And Repology said, no, you have a derivation, it should count. So numbers are, if you go to repology.org, are probably slightly exaggerated. I will get more into numbers about our package set later, a little bit. But still, I think Nixpkgs is I'd call it something like the Wikipedia of software or something. It's a really great collaboration project and a huge knowledge database. And this all culminates a little bit in NixOS. You can totally use Nix without NixOS, as you probably already know, but it gets much cooler with NixOS. So in the core, NixOS is basically one shell script that symlinks some packages somewhere, like to run current system, which you have in path, and it symlinks /etc, and then it copies your kernel onto your boot partition, and that's it. And so also this script in truth is much more complicated, but that is the idea. Let's write the whole operating system to the immutable store, and then we symlink the current generation. And when you want to update, you just run the activate script of your next generation, and you have instantly replaced all the installed software. And this gives you a lot of nice guarantee. Like you can do rollbacks, boot into an older generation if you haven't garbage collected it yet, which is controllable, of course. And it gives you a way to declaratively in Nix files track the whole description of your system, which I can't imagine living without. So, Nix has a bit of a reputation like Haskell of having bad to no documentation, but I don't think that's actually true. And some people are fighting the good fight of summarizing all of that on nix.dev. I think basically everything that you can find on documentation in that area can be found there. found there, and you're strongly encouraged to read it. One of the glorious pitfalls when reading Nix documentation is the core documentation is split into 3 manuals. There is a manual for Nix, the package manager, which also describes the language. And then there is a manual for Nixpkgs. And then there is a manual for NixOS. So just for orientation, the NixOS description of all the modules you can install on your system lives also in the Nixpkgs repository in one subfolder called NixOS. Yeah. And I'll just say it now, I'll say it later again. If you have any questions later about Haskell and nixos.org, you can, there are of course, other matrix rooms for NixOS, but Haskell.nix.org is a little bit of my home, so if you come there and ask a question, I'll probably answer it. Yeah?
Yes. Let's say you're not using NixOS, you're using it on another platform.
Yeah.
Is there a concept or a way to upgrade Nix itself as opposed to updating packages?
So the question was, if you use Nix on non-NixOS, can you update Nix itself? Yeah. Yes. I'm not exactly sure how to do it because I don't. But the point is, when you install Nix, you can install packages with it and put them in your environment. Like they get all symlinked to one folder in your home dir, and you put that home dir in path. And one of those packages then is already Nix. So you actually just update Nix with itself, because it just needs to replace the binary, which is just another new store path. The store itself is permanent and doesn't need much upgrading. Or if there is, there's probably migration. But that stuff has been fairly stable. So now we get to the big question, why Nix for Haskell? And Alex told me that this is a very important slide. And I told him I'm the wrong guy for the job, because I just don't know how to do it without Nix. I have no comparison much, and it just, I would describe it like administrating a system or doing a deployment without Nix feels to me a bit like coding without a version control system. It just feels not so good. So, but I will try to answer the question anyway, more seriously. So the first reason for me is that NixOS is really a great distribution. And when you use NixOS, you also probably need to interact with Nix when you're doing Haskell development. If you want to deploy on NixOS, by far the best way is to use the Nix infrastructure to deploy. Although you can, in theory, also just spawn a Docker container or something. Of course, that's also a possibility. And Nix is just great, yeah? Tracking your configuration in your repository, instantly migrate to a new machine when the first one breaks or something. And I can just say, especially for servers, the amount of server stuff I'm hosting wouldn't be possible without NixOS. It really decreases the amount of work that goes into maintaining a stable deployment. And but even without that, Nix can be very useful because of the reproducibility guarantees that you get. There's no more works on my machine situations if you can just build stuff with Nix. Of course, reproducibility can be a little bit confusing. We are not there yet to have bitwise reproducibility, but we have the reproducibility that mostly matters, which is when you build a derivation or when you evaluate one expression and then build the resulting derivation, you get basically the same software, and it even works 10 years later. Yes?
How does that reproducibility compare to the reproducibility
was high. So I mean, you talked about server deployments.
Yeah.
So how would you compare these?
I have to admit I don't have much experience with Docker, but so the question was, how does this compare with the reproducibility of Docker? And I'd say it's roughly the same. Alex, do you want to comment on that, or?
Okay. I think there are two things. One is that you can't control an entire operating system with one Docker image. You can have a single-purpose server on which you deploy a single application with a Docker image, or you can do orchestration stuff like with Kubernetes, and then that gets quite complicated. But the big problem I have with Docker and reproducibility is that if you have a Docker file and you build it on a different machine or on a different day, you'll get a different image. In particular, if you go apt-get install to install your dependencies, you will get whatever happens to be in the Ubuntu repositories on that day, whereas with NixOS or with Nix generally, you get exactly the same thing byte for byte every time.
Yeah. Yeah, that's a great description. I think with Nix you have a much tighter control about keeping the stuff that is relevant fixed and pinned, and it's not just, oh well, we just execute a bash script in a container and in a sandbox container, and then it will hopefully always do the same. Yeah.
Like with the reproducibility, like there are two parts of it. I guess the Nix part is always fully reproducible, but if you like copy dev random somewhere in your compiler, that part you can't fix on the Nix side, right? So is the Nix part itself fully reproducible?
I think so, yes.
Like
so,
Nix is Nix plus bash scripts doing random stuff. So.
Yeah. I'm very sure that, I'm totally sure that evaluating a Nix expression will always give you the exact same derivation with the same hash and the same content. There are right now actually competing implementations of Nix. There is at least one community-maintained fork, and there are other complete re-implementations, and they all aim and test themselves exactly to that standard, produce exactly the same derivations. But when you build the derivation, stuff gets very complicated. And there can be a lot of different problems. One would be that URLs that are cached in the store maybe disappear from the internet and are just not available at that point anymore. If you have already cached them, or they are cached on cache.nixos.org, everything is fine. If they are not, then building does not work anymore. And of course, a lot of compilers are just not reproducible, especially in the context of parallelism. And GHC is one of the offenders until now. I think it's getting much better, but I don't think we are already there yet.
Sorry, just to add that the Nix, the Docker images built with Nix, they are not bloated. They only contain the packages needed. So it just takes a snapshot of the packages that are getting installed after the derivation of the application you're building, and then it just copies those binaries to the target Docker image, as far as I know. I haven't used it, but I've seen some blogs talking about it. So it's really lean, like Nix builds really lean Docker images.
That's true. There is, of course, also the possibility of creating your Docker images with Nix if you want, for example, to deploy it in already an existing Kubernetes setup or something like that. And that's true. There is some smart logic in there to make small Docker images. Although, especially when doing it with Haskell, there can be pitfalls, because if you get all of GHC with all the core libraries and all the profiling libs and stuff like that into your closure, your Docker image will be large. That is, however, avoidable. I think I was still actually in my pitch for why Nix. And are there any more questions right now? If not, I'll just continue. So Nix gives you excellent dependency caching, which brings me back a little bit to one point that I missed. I said that you have derivations in your Nix store, and Nix runs the build to create the outputs. But when you actually tell Nix to, okay, I need this output on my system for what reason, whatever, then Nix first looks into all the binary caches you have configured. And you can host your own cache, or you will nearly always use cache.nixos.org, which is huge, humongous, and has a lot of binaries. And so Nix has this really nice interplay of being a source distribution and a binary distribution at the same time, and it very smoothly interacts. So when you use Nix for your Haskell project, you can set it up to have excellent caching. And I mean, we at work have one CI server which builds the environments, and all developers only need to download it, and everything works. Yeah, with Nix, you can provision your development environments. I mean, I think half of you already said you're using nix-shells, and that also gives you the possibility to have a very reproducible setup for all developers. In an open source project, that is good to keep the entry easy, and in a professional team, it's also quite helpful. And of course, Nixpkgs especially doesn't only describe Haskell packages, it also describes all other language ecosystems. So it's very easy to install system dependencies. And that will happen automatically when you build the shell environment for your Haskell project. And so maybe I give an overview over how that works later. And you can even do crazy stuff like describe in your project configurations how to use that you use multiple GHC versions and run tests on all of them. So you have an early warning system when your library doesn't work within your GHC or something like that. Is there any more arguments you want to throw into the pot? If not, I'll move on. Okay, then let's get to the, I don't know why there's an empty slide here. Let's get to the Haskell part of this. So I will talk about packages.haskell packages. As I said, this contains every package on Hackage and a few more custom maintained packages, and this all is defined in the Nixpkgs repository. And when you interact with Nix to build your Haskell project, you will by default use that infrastructure. It has two purposes, and that is sometimes there's sometimes a conflict there, because the first purpose of the Haskell infrastructure in Nixpkgs is to provide binaries of Haskell programs to NixOS users. So if we break pandoc, a lot of people get very mad. And shell check and other stuff, other software which is written in Haskell. And that is the primary purpose. And it is optimized to do this, and it is optimized to do this with not so much overhead. So we try to get a lot of library sharing between those binaries, which is like very different, for example, from packaging Node.js applications or something, where you just every program has a huge Node modules closure with thousands of different versions of the same library. That, I mean, doesn't work anyway with cabal, with Haskell or with Cabal especially, because it warns you about this. But yeah. There is actually a great blog post from Gabriela Gonzalez about local coherency and global coherency, where global coherency means we have a valid build plan for all packages at the same time, and local coherency means we just have a valid build plan for one package at a time. And we try to have a valid build plan for all packages at a time. And that's basically like Hackage does it, right? Anyways, what I'm not talking about, mainly because I don't know much about it, is Haskell.nix. It is at least very important for you to know that those are different things. Haskell.nix is basically a fork of the Haskell infrastructure Nixpkgs, which lives out of tree. You can look at it at this URL, and it really does some stuff a lot better. However, it is also quite a beast, and yeah, you will probably try to need to find out whether it solves your problems better when you get at the end of the capabilities of Nixpkgs, or whenever you want. But I can't really answer much questions about it. I had at least one situation where I just gave up building something with Nixpkgs and used Haskell.nix, and then I waited 5 hours, and then it just worked without intervention. So that is kind of the experience. You don't, yeah. Maybe we can talk more about this, but so the cornerstone of Haskell of the Haskell infrastructure and Nixpkgs is the cabal.nix program, and what does it? It's at the core. It's very simple. It takes a cabal file and creates a Nix derivation from it. The description of how to build that project. And how can you do that? Well, it's really easy. You just call cabal.nix, and then you point it to the directory of the package you want to build. Don't put the cabal file there, because then cabal.nix will try to be smart and fail. It has a lot of heuristics of fetching packages from URLs and stuff, but if you are in your own project, just do it like that, and you can, for example, pipe it into default.nix. And then that will look something like this. This is a project of mine, and what you can see here is some Nix package, some Nix magic. There is a Mic derivation over there, but all the others could be familiar Haskell packages to you, right? Async, extra. Is there S on somewhere in there? Oh no, I dropped that dependency. Okay, sure. Add to parsec, whatever. There's a question. Let's go.
Does cabal.nix expect only process only cabal files or .project files as well? The cabal project files.
No, it does not. It does not look into the cabal project file. Yeah. Okay. So this derivation goes on, and now you might ask a question like, so I'm building here version 2.1.6 of my program. But which version of async is it going to use? I probably have bounds if I'm a good citizen. I probably have bounds in my cabal file which say which version of async, for example, I want to use. But actually cabal.nix does not. Wait. I jumped a little bit there. Let's talk about this first. So how do you use this derivation? And you use it with call package. And there is a Nixpkgs wide call package called packages.callpackage. And then there's the Haskell call package in Haskell packages. So, and you point it at the default.nix. And actually, I think I'm missing curly braces open and close at the end before the semicolon. And there's this package you can then, for example, put into your NixOS configuration, and then you have the package installed. Or you can put it in your flake-nix or a default.nix. Maybe that would give you a recursion, but you know, in some other file. And that's just a value in the Nix language, and you can do whatever you want with the package. And so call package has a little bit of magic built in, because the whole default.nix that you see here is a lambda expression, which you can see from the column. And in the argument of the lambda expression, we are doing a pattern match, and we match on an attribute set or dictionary or an untyped record, right? And the values in there, they are in scope now, and then will be used lower in the derivation. And call package does some introspection into the function you are opening and figures out, okay, I need to give this function ANSI terminal and extra and STM and text and time and stuff like that. Yes?
From my understanding, coming from a type language, what will be the types of all these packages? Are they attribute sets or are they derivations?
Yeah, okay, so the question was, what are the types of the stuff? That's a good question. They are basically attribute sets. Yes. So they are a collection of keys. It's really a lot like in JavaScript, where basically everything is more or less an attribute set.
Well, it depends on how they were defined, because this is a fixed point over all packages in the package set. So for example, MK derivation, we take it as a parameter and then we use it as a function. So hopefully MK derivation has been defined as a function. If not, we have an application mismatch.
Yeah, that's true. That's a special case. MK derivation is not a Haskell dependency. This one is actually a function, which you can see because it is applied as a function right there.
Yeah, but it's not prescriptive. So for example, word 8, we will use as a derivation. So it had better be a derivation.
Yeah, exactly.
Which one would be a derivation?
Effectively on this slide, everything but MK derivation should be a derivation, but it's really by how you use it. These are just names.
Yeah. And so maybe to iterate it a little bit, word 8, for example, is an attribute set, so you can access fields in it. But it is an attribute set that represents a derivation, and that is basically based on duck typing, right? Because it has certain fields which make it a derivation. And of course, also because at some point it was generated by the make derivation prim op, which returns this attribute set which describes the package. Okay. How are we doing on time? Oh, well, we can easily fill the 2 hours. That's great.
Did you say that call package inspects the function to detect which arguments it needs?
Yes.
Why doesn't it just provide every Haskell package as an argument, and then the pattern match will pick out the correct ones?
Because this I mean, that would be possible, I guess, but I don't actually know exactly why it's designed. Maybe it's more performant. But anyway, if you do it exactly like this, the pattern match would fail because you would at least need a comma ... so that there would be additional arguments allowed. So this would, if it would do what you suggest right now, it would just give an error.
Doing it this way also allows you to override specific dependencies. So if you wanted to build your package with, say, a different version of transformers, you can supply that when you call package on the bottom line, and so you can customize what it uses as its dependencies.
Yeah, that is very true. Although I think it would also be possible in the other approach, but still very correct. We can override those packages, and maybe we will need to later.
Well, by virtue of being a fixed point, this set is actually not complete, so we cannot pass the whole set to functions that continue constructing the set.
That is a good point. Probably your own package is in the attribute set itself. And
well, if you don't use it, since it's lazily evaluated, it's probably fine.
Yeah, yeah. Okay, anyway, let's move on a little bit. So it picks a dependency from the package set. So it hopefully picks the one with the correct version, right? And it has to pick a valid version for the dependency, right? So no, it just doesn't. This infrastructure is very simple at this point. It will just give you the one async or the one STM or the one transformers which is defined in the package set. And if that doesn't match the bounds of your package, it will error during the configure phase and telling you that there isn't a valid build plan. And this is basically where maintainers come in. And why it's important that everyone loosens their bounds as far as correct and possible, right? Of course. So I want to tell you about one thing which is a shortcut a little bit. What I showed you before is first running cabal.nix to generate the expression and then calling call package to actually build the package out of that. And you can just do that in one step with the function call cabal.nix. And this is something which it's really simple and it works, but I actually don't really recommend that. But it's very common, and you should know about that, and you can probably just use it. But it behaves a little bit like template Haskell, because what it first does, it writes a derivation which runs cabal.nix. Then it runs the derivation to produce the nix expression, and then happens exactly what we were talking about before. Then nix reads again this expression in and evaluates it further. So we jump from the eval step to the build step, back to the eval step, and to the build step. And this is called import from derivation, and is for example forbidden in Nixpkgs. But in your own project, you can totally use it. It will, however, fail, for example, if you want to build for another platform, because then it will need to build the derivation, and it expects to build the derivation on the other platform. So you need to have a remote builder configured and stuff like that. That's not terribly complicated, but it is a little bit more complicated. And currently, the default GHC version, with which we build every package in Nixpkgs, is GHC 9.8. I will finish that sentence first. And then but we also have other GHC versions, for example, GHC 9.12. And you can use this expression to access that package set. That has, however, a little bit of complications. I can talk about that in a second. What's your question?
My question is about the previous slide, where Nix doesn't really pick the suitable dependency versions for your project. So if you have a Cabal project and you're using a Cabal freeze file to exactly pin the version for the non-Nix users, is there a way to ensure that both the Nix users and non-Nix users are using the exact same dependency versions in this scheme?
Yeah, that is an excellent question. So that is basically the main, one of the main upsides of the Haskell.nix infrastructure. And there are certain tools to also try it for the Nixpkgs infrastructure. And I'm basically planning to write one for years, but I haven't done so. There are some proof of concepts to actually create an overlay to Nixpkgs, which has exactly the versions from a cabal project freeze file, or however they are called, or also to actually directly create it from the output of a stack log file. There's actually a tool that does that. I think that works. And you can, what Haskell.nix also supports is calling cabal to get a plan.json, which is a valid build plan created by the cabal install solver, and create a package set from that. And that is also something I dearly miss. Yes?
Well, in vanilla Nixpkgs, we do have call Hackage, which allows you to manually specify versions. So it's not automatic from a freeze file, but if you have a small number of packages that you really want to pin down the versions for, you can do it manually to come closer to the build plan without any special fancy tooling.
Exactly. You can do it manually, and you can, and there are scripts which already try to do that manual stuff automatically from a freeze file, but nothing that is polished, I would say. Any more questions? Yes.
What happens to a sublibrary?
The question is, what happens to a sublibrary of Cabal? No, you mean when you have multiple libraries in your Cabal file, right? Yeah, that works. Nix just our derivation will just build it. Or I'm not sure what your question exactly was. Yeah. Okay. Maybe to make this completely clear, there is an interplay here, right? We have cabal.nix, which lives in its own repo, and it creates Nix derivations. Or Nix expressions to create a derivation. And that has to match, of course, the API of the package builder for Haskell packages, which is provided in Nixpkgs. And they both can, of course, co-evolve, and of course that happens, and we do that, but we rarely break anything.
For each package, is it forced that there's exactly one version for that name of a package? And is that why you also append a version to some packages? Like Python also has like the versions after it. I just saw that the GHC also has extra version stuff. Yeah, it's not part of the version, but it's in the name.
Yeah, I mean, all the attribute sets in Nixpkgs are key value maps, and the key has to be unique. So you can't have on a one package, you can't have multiple versions of the same package, but in Haskell packages, we sometimes create multiple versions of the same package, and then they are appended with the version number. That's exactly right. I will talk about that a little bit later. Any more questions at this point? I like this. Let's do this interactive. Okay, but we wanted to come to the task, and actually we are quite close there. The Haskell infrastructure is described in the manual, and the documentation is not great, but again better than it's given credit for, in my opinion. So let's come to the tasks. This is again the QR code, and it's basically constructed as an opinionated tutorial to configure your Haskell project with a Nix file, and now I'm not sure. Since there are so many people here who already have worked with Nix, maybe those exercises, I hope they are fairly beginner-friendly. Maybe you are not interested in doing them. If that's the case, I would maybe skip a little bit forward and tell you the other stuff I wanted to tell you. So we can make a break here, and maybe for 20 minutes or something, focus on the tasks, or we move on with me talking a little bit more. Who wants to focus on the tasks? Okay, and who would like to move on? Yeah, okay. So I guess then let's do that. The tasks don't run away, but maybe I will quickly talk a little bit about them so that you can. Can I copy that? Huh. This is. Where is my sidebar? That's not it. I want to see my tabs. Where's the tab bar? I don't get it. Ah, there, I know it. Sidebar is my tab bar. Okay, let's go. So these are the tasks. So the first is installing Nix. I hope that already works for most of you. And then, okay, I'm suggesting to use a flake in your project. If you have heard about Nix, you have probably heard that flakes is a contentious topic. But I will give you my reasoning. First, you really want to pin your dependencies. If you have a Nix derivation which leaves the Nixpkgs input unconstrained, then all your reproducibility goes out the window. And there are multiple tools to do that, but flakes is the only built-in tool to do that, so I should suggest you use flakes. And I think it's taking over even if it's maybe not the best solution, it's slowly taking over the ecosystem. So to do that, because it's so contentious, you need to enable experimental features, nix command and flakes. And I linked you their documentation, how you can do that, either in your NixOS config or a global nix conf, or you can just pass a flag with every call. So the whole idea of this task is of those tasks is to nixify a Haskell project. If you don't have one at hand, you can run cabal in it to create one in a new repository. And then I'm trying to guide you to build the package, and really this task 2 is all I want you to take away, right? Everything else is optional. There's a lot of cool and nice stuff you can do with Nix, but this is the whole flake that the minimal flake you would need to build your project, right? And I think that's pretty neat. It's not exactly how I would do it, but everything else is just fluff. It's just extra, and the important thing is I think the important thing is to understand how the package gets built with the cabal to nix call in this case. And if you do that in a flake or in a default.nix or whatever else approach, those are hurdles, I guess, since you need to learn all those formats. But in the core, they all do very similar things. What do you want to say, Alex?
Microphone? Notice that adding Nix to a Haskell project does not lead you to have to change any cabal or any Haskell files. So it stays a Haskell project, and you can always opt out. You can always delete the Nix files later without any damage to your project. So it's really low stakes.
That is very true. There's no danger in doing this, although I'm not legally taking any responsibility. But yeah. So and then we go on to I'm missing a new line here, and yeah. Then I go on to recommend flake utils, but you don't have to do that. And then configure a dev shell. I think this is like if you haven't done this before, this is really the cool part until where you should try to get. And then you have a Haskell language server in your project, and you can also install different stuff there, right? GHCID, if that's not what you, if Haskell language server isn't enough for you or doesn't work with your editor and stuff like that. Question?
What is nom build?
Yeah, well, that is a shameless plug by me. Nom build is the same as nix build, but it has nicer output, and yeah, that's a command from the Nix output monitor.
Do you have to install it? Like, because it says nom build.
Yeah, I have at some point here written how to install it. Yeah, you can, for example, load it into a shell like this. Yeah.
And nom is also written in Haskell.
It is written in Haskell, yeah, right. I really have people commenting on my repository, oh my god, this is useful software written in Haskell. And then I'm like, yeah, of course, there are also others, but some people are still surprised by that. Yeah, it's really nice. It uses streaming, it's a lot of fun to write it. And it gives you very colorful output, which makes a lot of people very happy, which I enjoy. Anyway, let's get back to it. As I said, I'm not a huge fan of this import from derivation stuff. It's not super important, but especially to understand how this all comes together, I really recommend generating the expression with cabal.nix yourself, and then replace call cabal.nix with call package. And then, of course, you have the problem that your default.nix can get stale with the generated expression, because every time you add a new dependency in your cabal file, that doesn't update. So the next automatically, the next step is to do that automatically. And I really recommend installing Git hooks to your repository. It's really cool. It supports a lot of pre-commit hooks for Git, which makes sure that your repository is in fine state. It can do HLint, it can do all the Haskell formatters it can use, and it has this cabal.nix enable line there, and that automatically runs cabal.nix every time you commit, and makes sure that your default.nix is in sync with your cabal file. And for example, in my personal CI, having the eval step and the build step separated is extremely useful, as it is in the NixOS CI. So I prefer it that way. And even if you don't use that cabal.nix hook, there are tons of others. Cabal guild, for example, if you don't know it, it's really nice because it can inject all the modules from your package into the cabal file. I mean, it's all just tiny comfort stuff, but yeah, I like it. And then it's super easy to get CI for that, right? You just have a small, if you're on GitHub, I do it on Forgeo, a self-hosted instance, but, or Gitty, can do it with GitLab similarly, but it's a really small file which just uses the install nix action and then does a nix flag check and a nix build. And then you have CI. And if you describe in your project a few more packages with different GHC versions, it's very easy to add other jobs too. Yeah. Then if your project has multiple cabal packages, I have here a task to get that to work exactly with the override like we heard before. And, well, I have not much instructions about doing multiple GHCs, but maybe you can figure it out, or we do it together. So those are the tasks. And then let's go to the preparation of the advanced task, fix the build of a Haskell package in Nixpkgs. But as I said, let's first talk about a little bit about the infrastructure there. So there is the tool cabal.nix. Any questions at this point? Here. Okay.
Zoom in a bit?
Zoom in a little bit. I can do that. I totally can do that. So there is the tool cabal.nix, which takes one cabal file and creates a Nix derivation. So why not scale it up? Write Hackage.nix, lives in the same directory, it's just another binary, of course written in Haskell. And that generates Nix expression for all of Hackage. Now, in Nixpkgs, this will create a Hackage.packages.nix file, and all of that lives in the Nixpkgs repository under packages development Haskell modules. So all other paths will be relative to that, besides this one. So how does this work? There is a YAML. There are multiple YAML config files somewhere in the Haskell modules tree, and then we run a script which lives in Nixpkgs under scripts maintainers Haskell regenerate hackage-packages.sh. And that will call Hackage.nix with a pinned version that we pin in Nixpkgs, and it will update the Hackage-packages.nix file, which lives in that Haskell modules folder. And this is, if you want to contribute anything, that is what you need to know. And now, and then we have tons of overrides, fixes, and stuff in different configuration files there. So which packages do we actually generate? It works like that. Hackage has about 17,000 packages, I think. This is basically what is listed on the Hackage site. And we generate derivations for nearly all of them. We exclude some which collide with Nix keywords. Anyway, then which version do we pick? Normally, we just pick the newest version which is available on Hackage. But in our config files, we also have a config file which is called stackage.yaml, which takes the current stackage LTS snapshot. And we have a script to update that. And then we pin the versions from Stackage. So generally, in NixOS Unstable, you can expect the versions of packages as they are in Stackage LTS. This is totally great for us because they all play together. There we don't have bound collisions, and this is, yeah. The guys at Stackage are doing amazing work, and that is super helpful for Nixpkgs. And if you want your package to be a good citizen of the ecosystem and to probably automatically just work and build in Nixpkgs without any more human intervention, go to Stackage and put your package on Stackage. And then you will get alerts if bounds don't match. And that is really, or you can do it for another package you like. You don't need to be the maintainer, right? And then the probability that it also works in Nixpkgs automatically is very high. So with this approach, Stackage has about 3,200 packages currently in the long-term support snapshot. And then there is, in Nixpkgs, we have derivations for all 17,000, but roughly 7,000 of them actually build. The others are just marked as broken. And I admit, when I first used the Haskell packages infrastructure, I was extremely annoyed because there were so many broken packages, more than half, right? And if you encounter a package, why is there a derivation if it's broken, right? That can be really annoying. But the fact is, we are doing this with very little maintainer power, and having 7,000 packages working is, in my opinion, really cool. Yeah.
Do you think we should use this to test breaking changes in the system? Like, because now I think we're only using Stackage, and these 7,000 extra packages.
Do I think we should use this to check for breakages in the ecosystem? That is a very good question, and I think it comes with complications, because those 7,000 packages built on our default GHC, which is currently 9.8. If you want to test some breakage, then you would need to do this on GHC head. And there's a downside to our approach, which is the package set that we define and that we fine-tune to build together is fine-tuned to build on the default GHC version. Now, GHC these days, this is important to me because I'm also on the GHC steering committee, does not permanently break your code. We really try to not do that. But GHC is also coupled with all the core libraries, and the snapshot altogether frequently breaks stuff. So when you use exactly the package set which builds fine on 9.8, it will probably not build fine on 9.12 currently. At least because every package should have an upper bound on base, and if you don't update it quickly enough, it will just not work. That is a bit of the conundrum there. This is also why using the non-default version of GHC in Nixpkgs is totally fine if you just want to install GHC and build stuff with that. That works perfectly. And if your closure is small, or for example, a subset of this closure of Haskell language server, then everything will be fine. But we cannot guarantee that every package builds with every GHC version.
More questions here?
Yeah, let's go. Question.
So what I was wondering was, the package description of a cabal package can change without changing the package version by modifying the revision. So I wonder how the Haskell Nixpkgs infrastructure deals with that kind of stuff.
Yes. It required a little bit of workarounds, but it is in place for years that those new revisions will get updated. So the pipeline is that somewhere in the Stackage infrastructure, there is an export of all cabal hashes of all of Hackage into one GitHub repository. And that information is very useful to us because it contains also the hashes for all the tarballs, and we use that in Nixpkgs to pin them. And that also contains the revision information. So when there is a revision released on Hackage, we also always use the newest one. Yes, exactly. So let's talk about the versioning a little bit, because there you might encounter packages like this. So what happens there? As on in Stackage right now is something 2 point, I don't know what, but there are some old packages which still haven't made the jump to as on 2.0, and so we need these other versions. This one is created by having an explicit line in our YAML config to generate it, but also when the version from Hackage, when the version from Stackage is not the newest version from Hackage, by default, we always generate a versioned package number, package with the newest version also. It's probably not a very good idea to rely on that much because it's a very moving target, but to get something to work quickly, it's totally fine. And I mean, if you pin your Nixpkgs, then it will say. So, tricks for packaging: upstream your package to Stackage, and you should, to be a good citizen of the ecosystem, you should test that your package works with Stackage LTS and the GHC, which is used in Stackage LTS until the newest GHC. That are my what I wish maintainers would do. And there's actually a bit of a conundrum here because it is super nice to pin your complete environment with Nixpkgs. But then please still test with a newer GHC version, not just the default version, because otherwise we can't update your package because it will be broken on a newer GHC possibly. And not because of the GHC, probably because of some library. Yes?
So what do you suggest when the latest GHC doesn't build our dependencies.
Yeah, that is one of the big ecosystem problems that we have, and I have talked to a lot of people about this on this Zuri hack. You can try to fix your dependencies with overrides, right? In an overlay to Haskell packages, and that is a little bit finicky, but maybe we can get into it a little bit later, although time is running a little bit short. Yeah, so this is the last part. If you're curious about this, I will go through it quickly. If we go to to this URL, I will try that. Then you can see what is currently broken on the Haskell updates branch in Nixpkgs. And you also see conveniently who's the maintainer. Oh, look there, a lot of packages which I maintain are broken. So this is work for me. And if you click on those links, you get directed to our build infrastructure, that's Hydra. And there you can see the build log to figure out what's wrong. And here, apparently, pandoc crossref, which I admittedly don't use anymore because I finished my thesis, but it requires a different pandoc version. So yeah, we would probably need to do something about that. I have an open pull request for Cabal to actually display which version of pandoc was found. If it's new or older, that would be very helpful here. Maybe to clear one confusion here, we are not using Cabal install to build packages in Nixpkgs. We are using setup.hs, which is just Cabal the library, which Stack and Cabal install both rely on. Okay. And also, of course, packages which are marked broken. Packages which are not maintained, we just automatically mark broken. And if they fail in CI. And if you want to prevent that, you can go to the main.yaml file and enter yourself as a maintainer, and then you get pinged when a package breaks. And that is normally very easy to fix. It just needs some attention. And if it's not easy to fix, I'm always there to help you or someone else. Yeah, so I guess this slide are the different things you can do to fix a broken package. Maybe we go into that if it comes up. I think I've talked enough now. Yeah. So we're not finished. You can still do your task and you can still ask all the questions, but we are at the end of my slides. I thank you for your attention until now, and then let's move on. Where are the tasks? Yeah. Let's go a few slides back. We have the QR code. It's code.maralon.de, the Zuri hack repo. Yeah. I kind of intend to convert the tasks into an opinionated tutorial later, which is more self-contained.
Quick question.
Yes.
About the key value pairs of the Nix store.
Yes.
Is the key not the hash and the name, or is the key just the name? I mean, can you maybe clear up?
Okay. When I talked about key values, so before I was, or key values, I was talking about address sets, right? The Nix store is really a directory on your system. It works like a file system, and I don't think it's technically possible. I mean, it's theoretically possible, but completely unlikely that for different packages with different names, the hashes will collide. So in practice, the hash is enough to.
Because you said there's only one for one package, there's only one version, right?
Yeah,
right,
but
right.
that is just in the Nix language, in the definition of packages.haskell packages. In packages.haskell packages, ason is exactly one package. It can't be multiple packages. It is just one. But you can, for example, use different commits of the Nixpkgs repository to install ason. Every time you just install packages.haskell packages.ason, and then in your Nix store, you will have all the different ason libraries under different hashes.
Right, because I use NixOS and I see that in the store you have the same package multiple times under different versions. So
yes, that is why that happens. And ideally, it goes away when you do a garbage collection, or they're actually required. I mean, this is one of the great strengths of Nix, right? That different programs can have different versions of the same library as a dependency. Yes, there in the front.
So if I use cabal.nix to build my package, you showed us how it sort of magically gives us all the packages as the arguments for that derivation. What if I want to use maybe a locally patched version of one of these packages? So how do I override this behavior of it providing all of those dependencies magically?
Yeah, that is what Alex referred to before. You can then override it. Let's maybe go to a terminal. So I can show you that. I have a test project here somewhere. Yeah. This is already much larger than usual. Okay. So what you can see here, I have here this first example package. Let's work a little bit on that. I will refactor it a little bit. Let's first factor out the package set. This is part of the first or the second task.
Let's also fix the GHC just as an example, like Haskell.packages.ghc 9.8 or something.
Yeah, we can do that later. I really want people to use the default because it's best maintained. So, okay, now first I bound Nixpkgs to the packages variable to get this more tamed. And now we want to have, we can have like, let's say this is one cabal project in one subfolder, and now you want, I don't know, my ason, which you have for some inexplicable reason forked ason. It's always my example package, I don't know. Then let's build ason here. And then I assume you put it in the subfolder there. And then it's really easy. We have these curly brackets at the end. And you need to somehow inject the ason into the Haskell packages. And there would be another way. We could call an override. What am I doing? We could call an override on Haskell packages that does some stuff. The KE is not really helpful there. AI. Anyway, but let's not do that right now because we can do it simpler. We can just use those curly brackets here at the end and override it. And we just do it like this. And now why is it complaining? That is the nil Nix language server. Very recommended, very helpful. And now, that's it. Now we have overridden the ason which my project is compiled with my ason. And to teach you a little bit about how nice Nix is, you can call this ason and then do this. And then you can maybe have a linter who tells you, oh, you can just call this inherit ason.
Well, with an override, it can get even nicer, right? Because you can apply patches to a package in place, which is probably the more pragmatic solution. So when you have a package that's already in Nixpkgs...
That is very true. That is very true. We could also do this, I mean, we can, overrides are so complicated. We can still do it without, right? We could just do s on here, and then we do something like packages, Haskell, lib, compose. Please don't ask about the compose. It's all the same library functions, but with better argument order. And then we do, we should really deprecate the other ones.
Override others, I guess you want.
What?
Override others, or?
No, I wanted to do append patch, I think. That's it called. And then, well, we need to find a patch from somewhere. There is a packages...
fetch patch.
Fetch patch something. And, yeah, and then a patch, right?
Yeah, and you can download a patch from GitHub. Let's say
and
there's an open PR against the...
Exactly. It's very easy here to now download the patch directly from GitHub, for example, if you need some fix in the library. And that makes it all very versatile. There are tons of examples of that in Nixpkgs in the configuration common.nix file, where we need to fix packages for one or the other reason. Yeah.
Is this a patch to the
No. This is about a patch to S on itself. This is patch for the Haskell code or for the cabal file. We have questions back there.
Just a matter of style. When do you think it's best to put stuff to do with fiddling about with one of your dependencies into a separate Nix file or a separate folder? And when is it better to have it up there in the top level in your flake, which is really about building your project rather than about your dependencies?
Yeah, I really don't have a good answer to this. It is really a question of taste. I would probably quickly start with, for example, when I need a set of overrides to fix something, then I often put that override in an extra package. But I think it's really a matter of, is it only 3 lines or is it 20, right?
I guess when you lose overview, it's probably a good idea to split things up.
Excuse me?
When overview becomes difficult, it might be.
Yeah, exactly. Something like that. Yeah. I think it's the same problem with Haskell modules, right? You need to figure out a sensible encapsulation.
What is the quickest way to just overwrite the source to point to the latest GitHub or a specific revision? Like, you often just want to get a quick patch in, and while you wait, you just want to use the latest sources that you...
Yeah, I think you can do something like override source, and then...
You can also call cabal.nix with fetch to GitHub. You can literally import a cabal project with GitHub.
Yes, exactly. So there are 2 ways to do it. If you really only want to override the source, you can do fetch from GitHub, right? Like this. And here, look for an example for how to specify the source there. And that works. Maybe you need to go into one subdirectory or something to get to the package you want. You can just do the whole call cabal.nix stuff, like here. But here you do a packages fetch from GitHub. Look at me type. Yeah, something like that. That can certainly work. And there are a few convenience functions. If it's, for example, already released on Hackage, then there is a call Hackage, and then you say something like is on 2.3, I don't know which version, anyway, something like this. This works. There is a snapshot of Hackage bundled into your pin of Nixpkgs, and if that snapshot is new enough, then this works. And so you don't need to give, for example, a hash for the source in this case. And if you don't know it, if it's not contained in that snapshot, there's another helper called Hackage Direct, where you need to actually specify a hash. All those functions are described in the Nixpkgs manual there. There are a lot of convenience functions. Another question, let's go.
It's not really a question, but I just want to share a bit my experience as a recreational Haskell packages contributor.
Yeah.
First of all, thanks for the great work. I think the whole Haskell packages has been very well maintained, has been very easy for me as a casual contributor to do. So what I recommend is none of the things here you can remember today, but it's very easy. Go to the repo of Nixpkgs, just copy the pattern. You know, there are gonna be some patches you can just copy paste and you will learn in no time. And in the fallback case, you can always go to metrics channel and ask the question, and people are very responsive. So I think it's very easy to contribute to the project, and you don't have to remember all the things that talked about here, in my experience. Thank you.
Yeah, thank you. I like to hear that. Here in front.
So in the Zurihack Nixtrack repository in the README,
yeah.
In task 4, you use Haskell packages.shell 4.
Yes.
And in the past, I've always just used the nix-shell function directly, the global one.
Yes.
And I was curious, what's the difference? Why should I change to the Haskell packages.shell 4?
Yeah, that is a good question. I think it is it just works specific for Haskell packages, because the packages parameter in the Haskell packages shell 4 expects a Haskell package, and it will do some magic to actually put all the dependencies of your project into your environment, so that Cabal, for example, can pick them up. That is the great selling point of using the nix-shell for your package. You really don't need to compile any dependencies with Cabal. And no, I lost my train of thought. Yeah, but I think that is the point. I mean, Nixpkgs uses an infrastructure there which is really nice and which is built into GHC, and basically no other tools use it. GHC itself has a package database, right? And this package database normally only contains the core packages, the boot packages that come bundled with GHC. There are about 20, right? It's everything needed to build GHC. And but with Nix, you can just pre-populate that database with packages compiled by Nix. And on my system, I have a lot of packages in there which are automatically available in every GHC shell, GHCI shell that I use, and also when I just compile a Haskell file. Alex? Those are actually system-wide, right? But of course, if you do it in a Nix shell, and you don't have a dir-env bug or something, the local environment will shadow the global environment, and it won't let you actually use the global environment there. So it's still encapsulated.
Earlier there was a question if this infrastructure can be used to test changes to GHC and such, and the answer was probably not, because there's a blessed GHC that's a bit behind. But there is a nice use case for generating package metadata which is not GHC dependent. For example, Hoogle. If you want to host a local Hoogle, the Nix package set is so rich and so nicely patched that it's super easy to host a local Hoogle with all the packages your heart can imagine, even if they're not in Stackage. And that's a super... Or, for example, if you have some tooling, like Simon Marlowe has the Glean code analysis tool, and he had to manually patch a bunch of things to make packages to build. Had he only used Nix packages, which I suggested, you can get a lot of this stuff for free, even if you're not using the latest GHC.
That is actually one argument for using shell 4, like in the task, because it has a with Hoogle flag, and you can just set it to true. Then it will have a Hoogle in your local database. And I think there was a talk on the ecosystem workshop, I think, from someone from Flipstone or something there, where they say all their customers, they are so happy about Google, but it should just be easy to self-host locally. And with Nix, it's really easy to self-host locally. You just run Google Web in your shell, and suck, you have a Google server running. Yeah.
Should we then migrate the actual global Google to use Nix packages?
That is an interesting proposition. Maybe.
The answer is yes.
Maybe. Okay, so maybe you have thought about this. I haven't thought about this, and I'm always like, Nix people can get very enthusiastic and missionary. I'm always a little bit careful about pushing Nix too much on other people, but I guess it could be a good idea. Yeah.
So did I hear correctly that you do not recommend call cabal to Nix?
Well, it's really fine. I don't like it in my setup, yes. I prefer the git hooks variant, but I think that's an outlier. I don't think that is super common. That is a me thing.
Yes, so I really don't like checking generated code into my Git repository.
Yeah, then don't. Then just use call cabal to Nix.
I like to have like one source of truth. But as you mentioned, you need to enable this experimental feature and switch back between the Nix phases. Couldn't.
It's not experimental.
Okay. So what was the thing called that generates the Nix code manually? Cabal to Nix, right?
Yes.
Yeah. So isn't there some pure function inside Cabal to Nix that you could just evaluate without evaluate from derivation?
That would mean re-implementing Cabal to Nix, which is written in Haskell in Nix. Doesn't seem very feasible. But
okay.
But it's theoretically it's an option, right? Yeah, exactly. MicroHS compiles to untitled lambda calculus and then execute that. Yeah.
So you mentioned at the beginning that if you Docker up some Haskell package, you can maybe end up packaging also GHC and the documentation and all the library.
Yeah.
How can we avoid to do so?
Yeah, excellent question. So there is a helper function in the Haskell lib which is called just static executables. If you apply that to a function, then to a Haskell package, it will basically do an RM on the library part at the end of the build and just keep the executable. And since a few Nixpkgs versions, it will also enable a check that you are really not depending on GHC, and if it depends, it will throw an error. So I think that is actually an improvement. And then you need to figure out why does your system depend on, why does the executable depend on GHC? It's somewhere, it will contain in the binary, it mentions a Nix store hash to probably one of your dependencies. And that's basically always the same bug. It always happens because of the cabal paths functionality. Well, there is an issue on the Nixpkgs tracker for that. And the fix normally is to call remove references to on that hash.
Okay, so what you mean is that there is a bug in the, like, it's an unwanted feature of the Nix code people could write that makes it happen. It's not just something that happens because of the tooling.
Well, I'm actually not sure. Alex, maybe you want to say something about that.
If you're packaging a project that has both a library and an executable component, then semantically speaking, your library will depend on GHC, simply because libraries are like ABI linked with GHC that produced them. So the first step to dropping or reducing the size of your closure would be to have a project that really is just a binary. It's just an executable. And in my experience, that's almost always enough to make a very small Docker image, let's say.
I mean, the big picture point here is that all the libraries which you can get compiled from Haskell packages, they are dynamically linked. they don't contain the code from all their dependencies, right? So if you want to use one library, you have to have all other libraries in scope, and you also have to have GHC in scope because it contains base and stuff like that. And then when we compile to the binary, the Haskell part of that binary will be static and will not contain, should not contain any links to other Haskell libraries. And there are, as again, there is basically a bug. I'm not sure who is exactly doing it wrong. If it's Cabal or GHC or we, yeah.
If I have multiple sub-projects in a Cabal project file, then you said you can't do that automatically with the Haskell packages in Nixpkgs, right? Or is there a way to extract some information at least?
Well, you can read in the Cabal project file with Nix.
And parse it with Nix?
And parse it with Nix, and then create an expression from that. One thing that I occasionally do is put all my Haskell projects in one subfolder, then iterate them with list directory in Nix and create one package for that. That's actually quite feasible. But it's not using the Cabal project file, yeah. So another question, let's go.
Yeah, I haven't used Nix before, so I'm going to ask a more abstract question, which is that all weekend I've heard people kind of grumbling that they're confused and stuff. Is there something inherently complicated about Nix, or is it just because there's some UX things that are still in progress?
Can I have this one?
What do you want to say?
Oh, can I have this one? Since
yeah, sure. Let's go.
Malte earlier excused himself that he can't really preach about the benefits because he doesn't know a life without Nix. I teach people Nix a lot, and I've observed that 90% of people who use Nix don't know what Nix is in an abstract sense. So when they come to you and they say you should use Nix, they're really selling you their solution to a small subset of problems which might not overlap with your problems, which is where the frustration comes from. I guess Malte mentioned documentation can be sometimes, let's say, people complain about it. It's scattered. It's not easy to find, to discover or navigate. That's a big problem that we also have in the Haskell community. If you know where to look and what to look for, how things look, you can learn it. I mean, we've all had to go through the same paces. We all have been there and we've managed to learn it. So clearly it's not missing, but there's also a curse of knowledge. Once you know how to do something, you forgot how hard it was to get there. So Nix people will tell you, oh, this will be easy, but then you spend 2 hours looking at errors. It's really very similar to the Haskell experience. And ultimately, I mean, it also doesn't work on Windows, which also means that a large demographic is not included. So
I have gotten bug reports for NOM not displaying stuff correctly on WSL, so it works a little bit on Windows, I think.
Yeah, WSL. Sure.
Yeah. I think Nix and Haskell are quite similar in that there is a steep learning curve. I mean, is it really sensible to expect from people to learn a programming language just to describe their operating system? That's not for everyone.
But
really.
It's also not fair to glue together Nix and the operating system, because you don't have to change your operating system to use Nix. And a lot of people think, oh, Nix sounds interesting, but I like my Arch or Ubuntu. I don't want to switch.
Yeah. But I think Nix has not always put also a little bit like Haskell maybe has not always put user experience at the top, and there are really a lot of rough edges, and that's being worked on and it's getting better. But then, yeah, it's a lot. Yeah.
I guess my take on Nix is that there is a lot of sometimes tooling, and sometimes the maintainers of a particular tool advertise it, and we tell also things that doesn't work, but you can sometimes discover it later. So you think, oh, I'm going to try this new tool, whether it's Haskell.nix or Higgs.nix or some other shell. And when you get excited because it has all these solutions, and when it doesn't work for one of your problems you have in your subset, and then you discover later. So sometimes it doesn't always say up front what something is good for and what it's not good for. An example is I use Haskell.nix quite a bit because we use Stack for various reasons, and I tried to use the infrastructure, but it didn't work because of the broken packages. So to me, it's news that I could have just used the stackage thing in the normal infrastructure, and presumably then it would have worked for my Stack project. But that little bit of information didn't come to me when I was exploring. So sometimes I feel like it would be nice to have a centralized place. We can almost have a table, Haskell.nix, pros and cons, infrastructure pros and cons, and some other things. So I think that kind of centralized comparison table, because we all seem to be reinventing the wheel by rediscovering the same.
There's a flowchart on the wiki.
So the NixOS wiki has a flowchart on the Haskell wiki page. It answers exactly your question, and it's deeply useless. Whenever I look at that flowchart, I always facepalm.
I think this makes clear one point, which is also very similar between the Haskell and the Nix ecosystems, is there are a lot of different solutions. Like I think like pinning your dependencies, it's a little bit like choosing an effect system, right? You just need to use one, but everyone uses a different one, and probably you just should stick to I/O to make it less complicated. I don't know, and I don't want to opine on this. So which
the Haskell page on wiki.
The Haskell page. One little side note, which probably no one tells you, is there is an outdated wiki at nixos.wiki. Please go to wiki.nixos.org.
Yeah, we even have two wikis. Yeah, one of which is unmaintained.
It's a very diverse ecosystem with different interests and people going missing on I don't know what. So here we have this flowchart. Okay, let's look at it. I need Nix tools, caching reproducibility.
Can you zoom in?
No. Yes, I can zoom in. Can you read the flowchart? Should be the first. Okay, I want reproducible. Wow, this is. Multiple sub-project, no. Develop package, yes. Yeah, I didn't tell you about develop package because I don't like it much, but it's fine, I guess. Complex project with heterogeneous team, no, yes. Yeah, no, I don't subscribe to this. I don't maintain this wiki page.
I told you it's useless.
I don't like this flowchart. Let's go.
Hi, one question. What is missing for Nix flakes to be usable without that experimental flag?
Consensus. I think, technically speaking, it has some design flaws which I don't expect to go away. And other than that, someone would need to write an RFC, and it would need to be accepted. And for various social issues, I'm not sure that's ever going to happen. I don't know. What?
Determinant Nix made flake stable.
Yeah, exactly. The determinant Nix is definitely part. Determinant systems is part of those social problems, right?
It's more of a social question than a technical question.
Yeah, totally. Yeah, I don't think there's much. I don't think anyone has a checklist of anything missing implementation-wise for flakes. And at this point, they are so widespread that I don't expect them to break them. It's not really an option.
I suspect there are quite a few people that have checklists on what's missing in flakes.
Okay, because you know them, yeah.
We talked briefly about the Hugel,
but
is it also possible to generate a browser for just the documentation of a whole set of packages? Is there an easy way to do that?
Well, I mean, the Hugel instance then links to the generated headocs, and they are completely correctly interlinked, and not completely correctly.
Cross-package, the linking breaks in the Nix store specifically.
Really?
I can show you later.
Not in all cases.
Not in all cases. Sometimes it's
okay. There's a way in which it can break. Not in my Hugel. I guess.
But yeah, we build all packages with haddocks by default.
So, is anyone working on the tasks? Is the other instructions a little bit clear? Okay, I hear no complaints. Yeah, next question.
Regarding the tasks, I guess you did not specify the starting conditions. I suppose you assume that you have GHC and Cabal already in your environment.
not really. But you can. I said you can run cabal in it, and yes, for that you need cabal in your environment. But you can always just do nix-shell, nixpkgs hash cabal install, and then you have cabal in your environment. And you can, of course, put it in your dev environment in your shell.nix. Any more questions? I mean, we are basically out of time. There in the back.
I also use NixOS as my daily driver, and I'm still not very familiar with the Haskell tooling. So when I run in an issue, I never know, is it now a Nix Haskell infrastructure issue, or is it a general issue with the Nix tooling, and where do I need to look for help? How can I find that out without like spending hours reading cabal docs or something?
Yeah, that's a tough one. I guess that's a general problem with modern software, right? It's so many layers, and you never know. Is it maybe just it's a memory fault, and you're not doing anything wrong. You just need a new RAM. I don't think that I can give you a satisfying answer to an abstract question like this. I can just say that I normally gladly answer questions in the NixOS chat.
I have a partly related follow-on question. So sometimes I guess maybe it's, for me, it feels like a question of composing flakes. For example, I might want to have some GitHub commit, what's that thing? Git hooks, right? And I might want to have some of them configured, and I want to export it to other projects. So I don't want to put the same text in every single flake in my project. So someone want to abstract out and easily import. Sometimes I want to have HLS, and it would be nice. So sometimes I guess the problems we have is probably not very crazy things like I want to have HLS, I want to have this type of linting, that type of linting. So it'd be nice if it would be like a set of flakes that can do just one thing and do it well, but be able to easily import into a project. So then instead of me trying to go to lower level details and understanding how cabal works or whatever, I can just take something that actually meets my need. So a question was, is there an easy way to compose flakes? I know about flake parts and all of that, but I tried to do some of them and sometimes I just would give up because it'll just be easier to copy paste. So, so is it possible to, what would be the recommended way to kind of compose flakes together?
It's a complicated. This is, you can put another layer of complexity on top of it, right? I mean, there is the Haskell flake, and there's flake parts, and all stuff like that, which tries to save you 3 to 4 lines, which I really think is detrimental if you don't know those 3 to 4 lines. I also just copy and paste flakes because,
There are solutions, there are existing solutions that do exactly what you ask for, but at various stages of maturity. And almost all of them are very niche, which means support is hard to find.
Just to clarify on this particular thing, I didn't want to save amount of lines. It's just like, if I want to improve how HLS works, for example, add another plugin or whatever, I don't want to recopy to every single project and keep a mental note.
So you can certainly do that. A flake has a certain amount of well-known outputs, right? But you can also put nix functions in a special in any output variable actually. And if you decide, well, I have this code that I need everywhere, and I want to update for all my packages at the same time, you can certainly make a utility flake for yourself and import it in all the other flakes. That's an option.
Also, flake templates are officially a thing.
That's
so project
also a thing. Exactly. Yeah. I mean, you see, I use Nix really every day, and I don't know all of that stuff, or use it at least. I have maybe seen it, but yeah. Okay. I mean, we are kind of The time is over, I guess, but I can still answer questions. It's okay. My train goes in a few hours. Back there.
Did you say anything about Nix flake update?
Nix flake what?
Update.
Update. Oh yeah, that's a good point. Yeah. So Nix flakes, Nix flake like other tools like nif or npins or something. They write your config, your dependencies to a log file, and you can update them whenever it pleases you. I like to use renovatebot for that, which does it automatically on my repositories. Yeah, that's of course. Otherwise, you stay on a stale version and you don't get new shiny packages and cool language features and stuff like that. But the call it's really just Nix flake update in your repository. Okay, thank you very much for being here for participating in the lively discussion. And yeah, that's it for me. And of course, I'm still around, and you know how to contact me online. So I'm always glad to help.